Hello, this video is for IXL Activity 8.W.1. It is titled Which X Satisfies an Equation. The three-character code for this activity is Bravo, Victor, Quebec. So whenever we evaluate something, we substitute in a value for it, right? So we're going to go ahead and evaluate each of these equations. They are equations because they have equal signs. We've kind of moved on from expressions to equations, so they are indeed equations, and thus we also see that word in the title. Remember that the root word for the word equation is equal, so remember that equations have equal signs in them. So we're going to evaluate each of these using the values that they give us, and we're going to see which one creates a true statement. The one that creates a true statement, well, that's going to be our correct answer. So, and that's known as, and if you get a true statement, then it's said that that value satisfies the equation because it creates a true statement. So let's go ahead and start off with this. It says 9s equals 81. So we're going to rewrite this, and we're just going to put parentheses in where the variable, in this case, the variable is s. And right now I'm sitting here thinking, why do they say which x satisfies the equation whenever they use other variables besides x? That's strange. So, but we're going to plug in these values here. So let's try this first one. Now, s equals 9. We plug that in. And then 9 times 9 equals 81. And does that equal 81? Indeed it does. So that's a true statement. That's going to work out. Now, if we'd have plugged in, if we'd tried the 11 first, and what we would have gotten there is, well, 9 times 11 is 99. Is 99 equal to 81? No, indeed, these two are not equal. Remember, drawing a slash through an equal sign means not equal. So this is a false statement. So the second choice here would be an incorrect answer. It does not satisfy the equation. So s equals 9 satisfies the equation. So it is indeed the correct answer. Next, always start off, rewrite the equation, and just simply put a parentheses wherever we see the variable at. Now let's go ahead and plug that in. Right now you're probably thinking, it's 10, it's 10. Well, let's go ahead and try the 9 first. The 9 comes first. I'll pretend I don't know that 2 times 10 is 20. 2 times 19 is 18. Is 18 equal to 20? No, indeed it is not. So this one doesn't work. So we can rule out t equals 9. However, 2 times t equals 20. Well, what if t is 10? Plug that in. 2 times 10 is 20. Does 20 equal 20? Indeed it does. So t equals 10 satisfies this equation. The next one, 16 equals 4 plus y. So we're going to do 16 equals 4 plus, and then whatever they give us, we'll plug in there. So let's do 11. And 16 equals 4 plus 11. 4 plus 11 is 15. So that's not true. That's a false statement. So this one here we can rule out. Now we're going to assume that the next one is a correct answer. Let's give that a try. What if we plug in a 12? And 16 equals 4 plus 12 is 16. Indeed, that is a true statement. So y equals 12 is a solution, or it satisfies the equation, we would say. On the next one, negative 2 equals d divided by 5 minus 2. So we have negative 2 equals whatever d is. I'm going to make parentheses for it, make it the numerator, put in that 5 for the denominator, and then we have to subtract 2. Or we could say plus negative 2, right? Kind of gotten used to that, hopefully, by now. And I'm looking right away. I realize that it's 0, because if we put in 0 here, 0 divided by 0 is going to make this go away, and negative 2 is going to equal negative 2. But again, I'll pretend I don't know that. Let's plug in the negative 10, and we would have negative 2 equals, well, negative divided by a positive is a negative. 10 divided by 5 is 2. So negative 10 divided by 5 is negative 2. And add to that a negative 2, and we would have negative 2 equals negative 2 plus negative 2 is negative 4. Is this a true statement? No, negative 2 is not equal to negative 4, so we could rule out negative 10. However, let's go back and let's go ahead and substitute in 0 instead. And then we would have negative 2 equals, and 0 divided by 5 is 0, plus the negative 2. And, well, anything plus 0 is itself, so we'd end up with negative 2 equals negative 2. This is indeed a true statement, so D minus 0 satisfies this equation. Well, look here. We have two variables this time, so we're going to have to do some more plugging stuff in there. And so let's rewrite it. 54 equals negative 4 times whatever z is, minus, and I'm going to change that subtraction to addition and then take the opposite of what comes next, which is the 5 times whatever z is. So let's go ahead and use the negative 6 first. Plug in negative 6, and it goes where both of those z's are at. So we end up with 54 equals negative 4 times negative 6 is positive 24, because a negative times a negative equals a positive. And then add to that negative 5 times negative 6. Negative times negative equals a positive. 5 times 6 is 30. And then 54 equals, well, 30 plus 24 is indeed 54. So this produces a true statement. So z equals negative 6 would be the correct answer. If we plug in negative 5, we'll find out that that would be an untrue statement. There's only one correct answer here, so we'll go ahead and go with that and realize that z equals negative 5. But let's see. If I was being a thorough teacher, I would go ahead and work that out. So let's go ahead and do that. We'll clear that out there. And so negative 4 times 5, and negative 5 times 5. So I'd end up with 54 equals negative times positive is a negative, and 4 times 5 is 20. And then add to that negative times a negative, or negative times positive is a negative. 5 times 5 is 25. So I would have 54 equals negative 20 plus negative 25. Well, they're both negative, so they're going to get more negative. And so that's going to be a negative number. And 20 plus 25 is going to be 45. So is 54 equal to negative 45? No, those two are not equal. So again, that one would not have worked. On to the next one here. Negative 2x minus 7x equals negative 27. So let's do negative 2 and then throw in the parentheses for the x. I'm going to change this subtraction to addition. Take the opposite of the next value, which is 7, negative 7, and then a parenthesis for the value of x equals negative 27. So let's go ahead and plug in. Let's go ahead and go with the negative 5. I'll just keep working left to right each time. And if I get the correct answer, then I'm going to understand the second one is incorrect. So negative 2 times negative 5, negative times negative is positive. 2 times 5 is 10. Plus negative times negative is positive. 7 times 5 is 35. And bring down negative 27. Well, we can see this isn't going to work out too well, is it? Equals negative 27. So that's going to be 45 equals negative 27. Nope, that is incorrect. And, yep, because it was a negative number, so it's going to make those positive. And so that didn't work out too well. And I'm realizing that if a positive number is going to have the opposite result, right? It's going to give me a different. I got a negative number, and this time I need a positive number. So I got a positive number. I need a negative number. So the negative number, because it was negative times negative, made positive. Now we're going to get a positive number like 3. We'll plug that 3 in there. So this ought to work out for us. Negative 2 times positive 3. Negative times positive is negative. 2 times 3 is 6. And negative times positive is negative. And 7 times 3 is 21. Equals negative 27. We're adding two negative numbers, so it's going to get even more negative. 21 plus 6 is 27. And does this equal negative 27? Indeed it does. So that checks out. So our correct answer is x equals 3. That satisfies this equation, so that is the correct answer. We're going along here. Let's take our 5t, and whatever the variable is, we're going to make a parenthesis. Let's change this subtraction over to addition. Take the opposite of what comes next, which is 25. Equals 10 times whatever t is. So we're going to put in parentheses there. Now, I'm thinking, if If I plug in the negative number, I'm going to get a negative number over here. You see what I'm thinking right here? I'm thinking if I put in the negative number times a positive number, I get a negative number over here. But positive number, let's go ahead and try the negative 5. We'll just keep working that left to right, okay? So negative 5, right? So negative times positive is negative. 5 times 5 is 25. And then we add to that negative 25. And 10 times negative 5 is negative 50, because a positive times negative equals negative. And then we're adding two negative numbers together, so it's going to give more negative. 25 plus 25 is 50. And bring down that negative 50 we had over on the right. And sure enough, the two of those, negative 50 is equal to negative 50. That is a true statement. So the first one is our correct answer. All right, on this next one here, before I do anything, I probably need to do this distributive property, right? Distribute that negative 5 into the quantity of y plus 2. So let's go ahead and do that first. Maybe I use some more room over here. So we're going to go negative 5 times y is going to be negative 5y. And then negative 5 times positive 2 is going to be negative 10. Well, let's make that plus negative 10. There, that 10's negative. And then we go ahead and keep going with the plus 12 equals negative 48. Okay, now I've done that distribution and distributed that negative 5 into the quantity of y plus 2. Now let's go ahead and make the parentheses for the y plus negative 10. And I'll tell you what, let's go ahead and simplify this a little more. Let's go ahead and do this negative 10 plus 12. So it's a negative number being added to a positive number, so we know I actually have to subtract. We'll take this greater absolute value of 12 and subtract 10 and get 2. And the 12 has a greater absolute value than the negative 10, so the 12 is going to win out. That means that 12 is positive, so our answer is positive, equals negative 48. Now let's go ahead and plug that value in. So our first possible choice is y equals negative 11. I kind of like this 10 though, right? I want to be a lot easier to multiply by 10. So let's try this one here first, okay? Let's go ahead and plug that 10 in there and try that out. So negative 5, I'm saying the answer already, aren't I? Negative 5 times 10, that's negative times positive, so that's a negative. 5 times 10 is 50, and we're going to add 2 to that. Equals negative 48. And if you're getting good at adding integers, you'll know that negative 50 plus 2 is going to be negative 48. And that equals negative 48. So this creates a true statement. So therefore, y equals 10 satisfies this equation. So that is the correct answer. And notice that strategy that I used, I figured a lot easier to multiply by 10. So that's the reason I tried that one out first. On the next one, it looks like we have a strategy we could employ here. Notice that 3z and negative 10z are both in the terms of z. So we could simplify this first. So it always helps to simplify it before we start our work. So we're going to bring down that 13 from right here. And if I have 3z's and negative 10z's, that's like 3 minus 10, which is the same as 3 plus negative 10. So we're going to have to, we're adding a positive and a negative number, which means we're actually going to subtract. So we're going to take 10 minus 3 and get 7. And the 10, negative 10, has a greater absolute value, and it's negative, so we're going to make our answer negative. So we have a negative 7z, right? And due to the fact that I like to keep this as addition, let's make that plus negative 7z. So now we can go ahead and substitute in. Let's do 27 equals 13 plus negative 7 times whatever z is. And I'm kind of liking this 1, right? Because anything times 1 is equal to itself. So let's try the 1 out first. That'll work well. Let's plug in that 1. So we get 27 equals 13 plus negative 7 times 1 is negative 7. And 13 plus negative 7, well, that's like, let's do that over here, 13 plus negative 7. So we are adding a positive and a negative number, so we're actually going to subtract. We're going to do 13 minus 7, and that's going to give us, I believe, 6, right? And the 13 has a greater absolute value, and it's positive, so our answer is going to be positive. So we're going to end up with 27 equals 6. Well, this is not a true statement, right? So we know that this one is not the correct answer, It must be the other one, but let's just verify that and be sure. We can go ahead and we'll just erase that right there. Take that stuff out there. I'm going to go ahead and erase this over here too. Get that out the way. And now we're going to plug in -2. And I think this one's going to work out maybe a little bit better. Yes, indeed it is, because I see what's going on here. It's going to be a positive number because it's negative times negative. And that'll help that 13 get up to 27. So 27 equals 13 plus, and negative times negative is positive. 7 times 2 is 14, so it's a positive 14. And so we get 27 equals 13 plus 14 is 27. Indeed, this is a true statement, so this is the correct answer. On the next one here, I think I'm going to need some space, so I'm going to erase this up here. Let's erase that up there and get us some more room to work, and I'll work this problem out here. I'll work up here. So looks like we need to distribute that -7 into the quantity of 6 plus z. So we'll go ahead and do that. The -45, and then we're going to have that equals, and then this -7 times 6 is a -42, and then we have -7 times z, positive z, so that's going to be a -7z minus 7z, and then we have -10, minus 10. And actually, let's make that plus -10, right? We could go ahead and do that. So I think I want to do a rewrite here. 45 equals -42, and this is going to be plus, change the subtraction to addition. The opposite of 7z is -7z plus -10. Now I think I want to simplify this a little bit more. -45 equals, let's combine the -42 and the -10 to have -52. -52. And now let's bring down that plus negative, oh, go backspace, -7, and then whatever z is. So there's our parentheses now. Let's go ahead and work with, it's -1, but I prefer -1 over -2, right? Let's put in -1 there, and we get -45 equals -52 plus negative times positive, or negative times negative is positive, so that's going to be a +7. So -45 equals -52 plus 7. So over here, -52 plus 7. Well, notice that I'm adding a positive and negative number together, so I actually need to subtract. So I'm going to get 52 minus 7, and that's going to give me 45, right? And the -52, and since the -52 has a greater absolute value than the 7, the negative wins out, so this is going to be a negative answer of -45, and that works really nice for us, don't it? Because -45 is indeed, yes, equal to -45. So z equals -1 satisfies this equation, so that's our correct answer. All right, last two problems here. Looks like both of them have distribution in them. We're going to have to use the good old property of multiplication over addition, distribution of multiplication over addition. Most people just call it the distributive property for short. So first thing we want to do is let's simplify this. We got to go ahead and do this distributive property here. So -5 times 8 is going to be -40, right? Negative times positive is a negative, and 8 times 5 is 40. And then -5 times positive x is going to be -5x. And notice how I just went ahead and made that addition and made the 5 a negative. And then I have -2 and equals 18. Now I could simplify this a little further. Let's go back to this -2 and make that plus a -2, right? That way everything's addition. You know, Mr. T, I kind of like it that way. So let's go at -40 plus -2. Well, we're adding two negative numbers together, so you guessed it, it's going to be more negative. And 40 plus 2 is not a tough one. That's 42, right? Which is the secret to life if you ever watch Hitchhiker's Guide to the Galaxy. Google it. Then let's bring down that 5x. So plus -5x equals 18. And tell you the truth, I like the -5x come first, so I'm going to write this as -5x and plus -42 equals 18. Commutative property of addition. I can switch those around. Remember, commute means to move, so change places, it's commutative property. And the next thing I need to do is that wherever this x is, I want to replace that, so I'm going to go ahead and just put in a parenthesis there. And then we got to try one of these two x's, and I got in that addition mark there. Squeeze that in there. So which one's easier? Multiplying by 11s is probably easier than multiplying by 12, so let's plug in that negative 11 right there, right? So negative times negative is positive. 5 times 11 is 55. And then I got plus a negative 42. And that equals, does that equal positive 18? Yeah, actually I think it will. Or at least pretty close to it. Let's check it out. 55 plus negative 42 is the same as 55 minus 42, right? So 5 minus 2 is 3, and 5 minus 4 is 1. So we get 13. Does 13 equal 18? No, that is not a true statement. So we can rule this one out. And on this one here, I think we should go back and verify that the 12 or the negative 12 works. Let's try that one out. So, and we'll erase this over here as well. So let's plug in a negative 12. Negative 12. And we need an addition sign right here, right? Get that plus sign in there. So negative times negative is positive. 5 times 12 is 60. And we're going to add to that a negative 42, which is the same as 60 minus 42. So let's go ahead and line that up over here. 60 minus 42. I need to borrow one, right? So the 6 becomes a 5, and the 0 becomes a 10. 10 minus 2 is 8. It looks like we're headed in the right direction. 5 minus 4 is 1. Voila, it equals 18. Does 18 equal 18? Indeed it does. So x equals negative 12 satisfies this equation. For the last one here, we have to do this distributive property here. So let's go ahead and do that. We got 44 equals negative 3 times positive 1. Well, negative times positive is negative. Anything times 1 is itself, so that's going to be negative 3. And negative 3 times u is going to be a negative 3u. Let's make that a plus negative 3u. Just made that quick change there. Change the this would have been negative times, that would have been minus 3u. And so I just changed subtraction to addition, took the opposite of 3u is negative 3u. And I don't want to lose anybody there. Plus 17. Looks like I can simplify this a little further. Let's bring down 44. We can combine the negative 3 and the positive 17. So we put those together. That's like 17 minus 3. So that's going to be 14. And then plus 3u. But instead of writing u, I'm going to put a parenthesis down because we're ready to plug it in there, substitute, and evaluate. So let's go ahead and do that. Even though it's a negative, I kind of like this 10. Multiplying by 10s is easy. So let's throw in that negative 10 first. So 44 equals 14. And plus, and positive times negative is negative. And then we're going to get negative 10. 3 times 10 is 30. And this isn't going to work out, is it? Because we start with 14, we're going to subtract 30. That's going to take us to the negative side. So without even doing the math, I already know that's probably not going to work out because that's going to take me to a negative number, and I want it to equal a positive number, and that positive number being 44. So let's plug in the 9 instead and try that. It should be it. Negative 10 didn't work. So we'll plug in that 9. So 44 equals 14 plus 3 times 9 is 27. And 44 equals, and 27 and 14, stack them up, 27, 14, 7 plus 4 is 11, carry the 1, and that equals 4. And, ooh, did I mess up someplace? Neither one's working. Let's see, start over. Did I mess something up? Negative times positive, negative times positive is negative. Positive times negative is negative. So it's negative 3u. Bring down my 17. 17 plus negative 3 is 14. Let's plug in a 9. And that is 44. 9 times 3, last time I checked, is 27. 27 plus 14. 27, 37, 41. That equals 41. did I mess up on the 10? Because neither one's working. Double check my work up here. There's another way we could do that. And yeah, let's go ahead and try it. Let's see what it looks like before we even simplify. Let's try that strategy. Because you don't have to simplify it. I just, out of habit, I simplify it. So let's go ahead and try this. Let's do 44 equals negative 3 times the quantity of 1, take away that, 1 plus whatever u is, put a parentheses there, parentheses to hold all that in, plus 17. So now let's go ahead and plug in, let's go ahead and plug in the, well, we tried the 9, it didn't work, so let's plug in the negative 10. Let's try that. So we get 44 equals negative 3, and 1 plus negative 10. 1 plus negative 10 is, oh, that's the same as 1 minus 10. So we're going to get negative 9 plus 17, and 44 equals 3 times negative 9 is 27. Oh, that's going to work out. Yeah, so I messed up on the, I plugged in negative 10. Remember, we plugged in negative 10, so my math was wrong that first time. It looks like this is going to work out. So plus 17 and 44 equals 27 plus 17, 4, 1, 4, indeed it equals 44. And now we see this negative 9 showing up. We're seeing a 9 here. Remember, this is what we plugged in right here, this negative 10. So this is the one that works out. So see, and I intentionally got it wrong, so I wanted to demonstrate that even teachers mess up sometimes too. Do you believe me? Oh, got in a hurry. Happens sometimes. All right, so those are all of my examples for IXL 8.W.1, which X satisfies an equation. Good luck with your activities.